All right, ladies and gentlemen, in this video we are continuing with our success criteria in which we are going to identify vertical angles and linear pairs, and we are going to use the following to find some missing angle measures. So let's first and foremost define what vertical angles are. Vertical angles are just simply angles that are created by crossing lines. That's it. That is literally all that vertical angles are. So 3 and 4 are considered vertical angles because they are across the two lines that are crossing. And then 1 and 2 are considered vertical angles across from one another. And so the key takeaway here is what can we conclude about vertical angles? Well, down here it says the measure of angle 1 equals the measure of angle 2 and 3 equals the measure of 4. Well, how is this possible? Well, let's think about this. This line right here is a straight line. So that means 2 plus 3 together would make a straight line, or it would be supplementary to one another. Okay, so let's just say, for instance, that this is a value of, I don't know, 40 degrees. So giving a random number to it. So if together they would have to be 180, that means that this would also have to be 180 or 140 degrees. Well, now let's compare on this line. Well, this is also a straight line, so that means 3 and 1 also have to be supplementary to make a straight line. Well, if 3 is already 140, then 1 would have to be 40 degrees. Are you noticing a pattern? If 1 and 4 form a straight line and 1 is already 40 degrees, then 4 has to be 140 degrees as well as 3. So since they are equal in measure, this is the key thing to realize, is that the vertical angles are congruent. Vertical angles are congruent. And that is called the vertical angles congruency theorem. That all vertical angles are congruent. Now we will be doing a lot with those proofs. At some point we get into chapter 2, but for right now I just kind of wanted to tease that out there. So let's take a look here at what we can identify utilizing some different angle pair relationships, and let's kind of just keep in mind of what do we actually know, right? So far we've classified vertical angles, we've classified supplementary angles, we've classified a right angle. So let's continue on. So it says angle 1 and angle 2. Well, what could we call these? Well, right now, all we can really call these are adjacent angles. They're adjacent angles that are supplementary. So angle 1 and angle 2, these are just two adjacent angles that are supplementary. What about 1 and 3? Well, angle 1 and angle 3, here's our two crossing lines, and number 1 and number 3, those are considered vertical angles. What about 3 and 5? Well, between 3 and 5, they kind of look like vertical angles, but honestly, they're not really a whole lot of anything. So there's no real classification for for angle 3 and 5. Let's take a look at angle 2 and angle 4. So 2 and 4 right here. Again, tempting to call them vertical, but it's not the same two lines that are creating the crossing angles. So 2 and 4 really have no relationship either. What about a couple scenarios here? If the measure of angle 1 is 36 degrees, we have a straight angle of 180 degrees happening right here. So that means the angle addition postulate would say that the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. So that means 2 would be 180 minus 36, or we would get 144 degrees for the measure of angle 2. And if this is the case that 1 and 3 were vertical, well, remember we talked about vertical angles are congruent, so that means the measure would also be 36 degrees. Let's take a look here at one other pair of angle relationships, and that is called a linear pair. Now we just saw a lot of linear pairs. We just saw a lot of linear pairs happening in these last couple of examples. And simply put, linear pair is two adjacent angles that make a straight line. Now let me make this clear. Most students forget the linear pair more than anything else. I'm not sure why, but somehow, some way, it always kind of seeps through that brain of theirs. So try your best to make sure that you remember this linear pair. And here's how I think about it. It's a pair of angles that form a line. A pair of angles that form a line, hence a linear pair. And since a straight line equals 180 degrees, linear pairs are supplementary. So let's take a look here at an example in which we can kind of show a connection between all of these angle pair relationships. In this example, it says to solve for x and to solve for y. So let's take a look here. Well, what I always want you guys to take a look at first is, are vertical angles possible to use? Why? Because vertical angles are always going to be congruent to each other. So 9 times out of 10, it's just easier to set two expressions equal to each other. But let's take a look at what would happen here. I have a vertical angle here, and I have a vertical angle here as well too. So yeah, I could set them equal to each other, but what would happen? Hopefully you realize that you would have two different variables. Same thing here, you'd have two different variables. So let's look at what we now know about linear pairs. I have a linear pair here and here. So here's a linear pair and here's another linear pair. And we both know that linear pairs add up to 180 degrees. So that means 5x plus 30 plus 4x plus 15 will have to equal 180 degrees. This is more beneficial because we have two of the same variable in our equation. So 9x equals, whoops, let's kind of step back. I don't want to skip too far ahead here. 9x plus 45 equals 180 degrees. And now we can subtract by 145, and of course we're going to get 135. So 9x equals 135. And then we're just dividing by 9, and then x has a value of 15. All right, so now x has a value of 15. I'm going to use that to my advantage, and there's a little p that kind of can't see in there, so I'm going to put that p at the intersection. So if x is 15, if I substitute that into here, 5 times 15 plus 30, all right, well, we have 5 times 15 plus 30 ends up giving us 105. And I don't really need to substitute 15 in here, because if the whole thing is 180, 180 minus 105 is going to just give us 75, and we kind of know that that's going to be a linear pair anyway. Well, now look what happens. Now we have vertical angles. So now this value is also 105, and this value is also 75 degrees. Well, this helps us to find out the value of y a lot easier, because now I can say that 3y minus 15 simply equals 75, and 3y equals 90, and then y, of course, is a value of 30 in the end. So we found the value of x, we found the value of y, we found all of our missing angles, and we kind of used a combination of all vertical angles and linear pairs. So let's recap. Vertical angles are congruent. Linear pairs are two adjacent angles that add up to 180 degrees because they form a straight line.